Hey class, Mr. Moedin here with a video lesson on the law of cosines. Last time we learned about the law of sines, which allows us to find missing sides or angles in a non-right triangle. On the screen here is a non-right triangle, but you'll notice that the law of sines will not work. The reason is, to use a law of sines, you need a complete set of side and opposite angle. So for example, we have 41 degrees, but we don't know the side opposite it from it. And that's a problem. We have 29, but we don't know angle A opposite from it, and we have 13, but we don't know angle B opposite from it. So the law of sines here completely fails. In the scenario where the law of sines fails, we have a backup option, and that is the law of cosines. But to highlight here, you should always try to use the law of sines first. In general, it's a bit easier to use the law of sines than cosines, as you might find, but you should try to use sines first, and if it fails, cosines is your backup. And to use a law of sines, as we just saw, you would need a complete set of side and angle, which this triangle on the screen here lacks. So what is this mysterious formula and how do we use it? Let's take a look. The naming process for the law of cosines is the same as before. Across from an angle, we call the side a lowercase version of the same letter. So down here, little b, and then across from C, we have a lowercase c. Now my C's, uppercase and lowercase, look kind of alike. So to distinguish uppercase, I like to put serifs on my C to make it clear that's uppercase C. Now the formula is not something we'll prove. I'm just going to go ahead and give you the formula, and here it is. And it can look a little intimidating at first, but I do want to mention here that you definitely must memorize this formula. It is something you need to know cold for assessments, for homeworks and whatnot. It's something that should become second nature to you. That can be intimidating, but if you notice, there are two ways to kind of remember the way this formula works. The first half of this formula actually is something you already know. This right here, of course, is just a Pythagorean theorem, perhaps in reverse from what you normally think of it as, but it's still c squared equals b squared plus a squared. All that's added in addition to it is this negative 2ab times cosine of angle C. That's the only difference here. And then this might help. It doesn't help everybody, but it's sort of a study tip. You'll notice that the order of the letters here goes C, B, A, and then it follows up with A, B, C. So that might help you remember the specific ordering of the parts of the law of cosines. And to use it, essentially, when you're looking for a missing side, if the question says find this length, then call the side you're looking for in a law of cosines problem lowercase c. And the reason for that is, by the way, you'll notice lowercase c is already basically by itself here on this side of the equal sign, so solving for it will become very easy. If, however, you're looking for an angle using the law of cosines, then you should call that angle uppercase c, because uppercase c here is the only angle in this entire formula. So if you're going to use this formula, you may as well call the angle you're looking for uppercase c. So with an example here, the question says find the length of DF round to the nearest thousandths. Let me try to use the law of sines first, but it's going to be a pretty short operation here because I don't have that set, because I'm missing DF, obviously. I don't have this set because I'm missing angle F, and I don't have this set because I'm missing angle D. I have no complete set of side and angle, both known, so this is definitely going to be a law of cosines problems. Let me write down the formula, which again you will need to have memorized. There's a Pythagorean theorem, and then one additional part, which is that. Now, we're asked to find DF, which is this length right here, and my strategy for this is to call the length I'm looking for lowercase c. That automatically makes angle E here relabeled to become uppercase c. And a nice feature of this formula is the fact that A and B do the same things in the formula. Both A and B are both squared and multiplied, so I can call either of the other points A or B, and then of course the other vertex can be the other letter. So I've called A and B 27 and 9, but you could have also done 9 and 27 if you prefer. So plugging everything in, we get c squared equals 9 squared, it's a 9, plus 27 squared, minus 2 times those numbers again, 27 and 9, times the cosine of the angle in between them, which is angle C, which was the given angle in the problem. And that's a lot of numbers here, and it's actually a good thing because this entire side of the equal sign is just known values. They're all numbers there that we can actually use the calculator in one step to make into a much smaller piece of our equation. So I'm getting my calculator here. What I can do is literally type in what's on my page there. Minus, excuse me, 2 times those numbers again, times the cosine of the angle. So c squared is that number, about 960-ish. So c squared is about 960 point something, something, something. I'm not rounding yet because I want c, the length df. And what I found is c squared, so all I got to do is take the square root of that number. And now I have c, going back to my calculator here, simply being the square root of this value, which I can go up here, the calculator, press enter to bring it down. The square root of that full value to the nearest thousandth is 30.987 approximately. Super simple. Law of cosines to find a missing side, really not so bad. I tried using sines first, didn't work, so cosines is my backup. Another example, find the length of CB, which is this piece right here. Now this triangle is already labeled ABC, so I might be tempted to use the labels, but I actually shouldn't. I'm asked to find this length right here, so I'm going to call it little c, which means that this needs to be uppercase C. And I already have a B over here, so the other one needs to be called A, and that's therefore little a, and that over here therefore is 17 little b. So plugging everything in, 17 is going to be my b, so 17 squared plus 10 squared minus 2 times those numbers times the cosine of the angle between them. Now I'm going to cut it off here just to keep this video a bit shorter, but I hope you can see that this is exactly like the previous problem in terms of what to do. You type in your numbers once you've relabeled everything, you put it in the calculator, take the square root, you get your answer, and you call it a day. Law of cosines to find a side, really not so bad. So to summarize where we are so far, I have 4 problems here that I encourage you to pause the video and think about. Is each one a law of sines problem or a law of cosines problem? Because one challenge students have is to figure out, all right, we have these new formulas, which ones do we use in which cases? So think about it and then press play to figure out the answers. So in A, we are going to use the law of cosines. And hopefully you see the reason for that is I don't have the angle across from 8. I don't have the angle across from 12. I don't have the side across from 15. Sines fails, so cosine comes in and saves the day. B, meanwhile, is a textbook case of the law of sines because of this complete set. And C is also a case of the law of sines, but you may be wondering, well, I don't have the angle across from 15, do I? But actually I do, because any triangle makes 180. So from 180, simply take away 80 and 22. Oh, hey, that angle is 78. And now you can see this is a law of sines problem. And finally here, picture D is a sines problem as well. And you can see that because we have this set right here. If you have this set of both values known, law of sines. If you don't, law of cosines. There is, however, a scenario that I have not illustrated on the screen here that merits discussion, and that is the hardest kind of problem you're going to encounter in Skill 5D, and that is the side, side, side scenario, where all you have are 3 sides, and the task is to find the measure of one of the angles. In this case, we're asked to find angle P. So clearly, law of sines is going to fail here because with no angles given, there is no way to get a complete set of side and angle. So we're going to use this formula, and you'll notice that this formula only has one angle in it, and that angle is called uppercase C. So it would make sense then that as a starting point, if we're asked to find angle P, let's just temporarily call the angle we're looking for uppercase C, and then solve for uppercase C using some arithmetic. So that makes 17 little c. That makes R A or B, and then Q B or A, and then the other numbers over here, the opposites of A and B. And we plug everything in and we solve for C. Easier said than done, but let's go ahead and start by putting in our numbers in the appropriate places. Again, A and B are just interchangeable, as you can see by the commutative property. Cosine of, well, I don't know what angle C is, so I'm going to put that as my variable, cosine of angle C. So what follows now is a bunch of arithmetic, some of which you can do in the calculator to make it easier, but not all of which. So 289 is 17 squared, 15 squared is 225, 28 squared, I'll confess I do not know. It's 784. Now, I'm following the order of operations, which, just as a reminder, you may have learned as PEMDAS. So I'm taking care of my exponents right here, and then I have some multiplication right there. So I'm multiplying -2 times 28 times 15 right here. So in the calculator, -2 times 28 times 15, that's -840. And then multiplied by that is cosine of c, which of course I don't know, so I'm just going to leave that as negative cosine of c. So what can I combine? Well, I have a number added to a number minus a number multiplied by this variable. These are not like terms. Again, these are not like terms. I cannot combine them. I can, however, combine these. 225 plus 784, that's pretty straightforward. I can just combine those in the calculator or by hand if I was feeling into it. I'll get 1009 either way. So 289 equals 1009 minus 840 cosine of c. Again, I cannot combine these because one has a variable cosine of c and the other one doesn't. Didn't mean for that. So let's go ahead and subtract the 1009 from both sides. Let me get rid of this bar here. So subtract 1009. The reason I'm doing this is I'm trying to get angle C, formerly known as angle P. And the more I get cosine of C isolated, the closer I'll be to getting C isolated. So 289 minus 1009. I'll confess I also don't know. Could probably do that in my head, but not feeling interested in doing that. Negative 720 equals negative 840 cosine of C. Don't forget this negative right here. Important to bring it along. Oops. And then to get cosine of C by itself, all one needs to do is to divide both sides by negative 840, which is going to be a positive number because of the way negatives work. So negative 720 divided by negative 840 gives us this decimal 0.857, blah, 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 blah. And that equals cosine of C. Well, this should look familiar. We know the ratio. All we got to do is work backwards to find the angle. Well, that's a textbook case of using the inverse cosine operation. If cosine of C is equal to this decimal, then apply the inverse of cosine to both sides. These will cancel because inverses cancel the thing they are inverting. And that'll leave us with just C over here, the angle we're looking for. And inverse cosine of this decimal is something the calculator can take care of for us very easily. Inverse cosine of that number I have stored in my memory, second cosine, inverse cosine, go up here and bring it, of this is 31 degrees, which is about how cold it feels in this room right now, by the way. To get my heater fixed. And there we go. Law of cosines to find an angle. Not quite as easy as using the law of cosines to find a side, but if you're careful with your order of operations and basic, arithmetic here, really not so bad. So make sure you watch out for like terms and not to combine unlike terms. So what I mean by that, going back to the complete work here, let me grab a highlighter. These right here are like terms. I combine them. Great. These right here are not like terms. And the reason is one has a cosine attached to it over here and one doesn't. So I didn't combine them. I moved the 1009 to the other side to combine with 289 and then divided and so on and solved to get 31 degrees. So that should put you in a good shape to practice with the law of cosines. Good luck.